Hello friends and welcome at my channel. Today I would like to show you guys one new graph of a hyperbola which is kind of similar to the previous result, but you will see a slight difference in the numerator leads to a totally different graph. So let me put it ahead. F of x is equal to x to the power of 4 plus 3 divided over x. And if you compare it to the previous video, which I'm linking here, it was x to the power of 4 minus 3 plus x. So it should be very similar, especially considering the behavior towards 0 from both hand sides. Obviously, x is not equal to 0 here. Also, the behavior towards plus or minus infinity must be the same because plus 3 isn't changing there anything. But we will see also some more issues. One of which is we have no 0 points, obviously, because the numerator is always positive. So let's start. First point, the domain x is unequal to 0. We're done. Second point, what do we have? Well, if we are talking about symmetry, it's obviously the same that we had yesterday. F of minus x is equal to minus x to the power of 4 plus 3 divided over minus x, which is x to the power of 4 plus 3 divided over minus x, which is minus x to the power of 4 plus 3 divided by x, which is minus f of x. So we are symmetric considering the origin, which is nice to have. Number 3, let's consider all the limits. I'm just writing them down. I mean, x towards infinity of f of x. This is plus infinity, and because of the symmetry again, I don't have to compute that much. That would be minus infinity. All right, next one. Yeah, about 0. Limit x towards 0 from the right-hand side, and once again, because of the symmetry, once I've got this, I immediately know what's happening from if I'm approaching the 0 value from the other side. So if we are approaching 0 from the right-hand side, we are dividing a positive number, which is slightly bigger than 3, by a tiny small positive number as well, so the result is plus infinity. And obviously, if we are approaching 0 from the negative side of f of x, the result would be minus infinity. All right, we got it. Number 4, 0 points. X to the power of 4 plus 3 divided over x equals to 0. Well, it's never 0 because the denominator is making no troubles. Actually, the denominator is never helping us to get to 0. It can help us to approach 0, but we're never strictly at 0 just because of the denominator, but the numerator must be equal to 0, which is not the case here because x to the power of 4 plus 3 is just strictly over 0 all the time. So no 0 points. Sorry about that. Number 4, extreme values. For these reasons, we need to compute the derivative, which is once again the quotient rule. So we got 4x cubed times x minus x to the power of 4 plus 3 times 1 divided over x squared. Can we simplify it? Well, we could try 4x to the power of 4 minus x to the power of 4 minus 3. Hope I didn't make any mistake. 3x to the power of 4 minus 3 divided over x squared. There you go. Do we have 0 points? Oh yeah, we do. So once again, the same story. We're just only considering the numerator, which is this guy. X to the power of 4 must be equal to 1, so x is equal to minus 1 or to plus 1. It depends on how you write it. At your school or university, normally we're taking the fourth root. Actually, in order to be totally precise, we have 4 0 points, 2 of which were minus 1 and 2 more are plus 1. But actually, geometrically, we just only have 2. All right, I do have to compute the second derivative anyway because I would like to compute the points of inflection. So I do it anyway. Just change the color. So what about the second prime of x? Well, we're going to get 12x squared times x squared minus, parentheses opened, 3x open, 3x to the power of 4 minus 3 times 2x. That's all right, divided over x to the power of 4. So we have 12x to the power of 4. We have minus 6x to the power of 5, if I'm not mistaken, and then plus we have 6x. All right, divided over x to the power of 4. I cannot simplify that much actually. Let me check. I was wrong, right? 12x cubed here. That's why it's 12x to the power of 5. I'm sorry. I have to slightly change it. I will do. No problem. Everybody's human. We're making mistakes. It's not hard, kind of theoretically, to compute it, but you have to stay focused all the time and just slight distraction, not necessarily from refill outside, but also maybe something in your head, and you're already lost. You see, I was feeling something is wrong, so I'm happy I've done it. So 12x to the power of 5, let's check it again, minus and plus, that should be fine. So we can combine it, it's 6x to the power of 5 plus 6x divided over x to the power of 4, and now we can cancel 1x at least, because we know that x is not allowed to be 0. Anyway, so we got 6x to the power of 4 plus 6 just divided by x cubed. All right. Once again, because of the symmetry, I don't have to check both points. It's enough if I'm just checking only one, which I'm going to be doing with 1. So what is f second prime at 1? This is 12 divided by 1, which is 12, so it's positive. That means we're going up after it, so it's a min. I have a min at 1, and this was our function, right? So 4 divided by 1, 1 and 4 is a minimum. And once again, because of the symmetry, we are having a max because of the symmetry. We're having max at minus 1, minus 4. That's it. If I have a quick look at the second derivative, at the numerator of the second derivative, I clearly see that this guy is always greater than 0. So I'm having no points of inflection. Let's go. So number 6, 6x to the power of 4 plus 6 is always greater than 0. So that means no points of inflection. That's it. And number 7 is the graph. Let's see what's happening. All right, so what do we have? We have at 1, 4 and minus 1, minus 4, somewhere there. Mix, mix. That's right, total mix. The maximum and the minimum of the function. We're going to plus infinity from the right-hand side. We're going to minus infinity from the left-hand side. We're going to plus infinity. Let me write it here for you to be able to go with me. All right. So that means we're going like that. And once I understand what's happening here, I totally like reflect what's happening there. So it should be the same graph. All right. So this is how it looks like. Thanks for watching and see you guys in the next video. All the best. Bye-bye.